Just recall the points of the previous lecture. Hmm, okay then. Hmm. So in the last lecture, we have seen the directional derivative, that is finding the derivative along the different direction of the vector, right? So in that case, we have seen the different type of examples. That is along a bar, we can find the derivative. Then along the tangent to the curve, tangent, that is dr bar upon dt. Then we can find along the normal to the surface, normal to the surface, that is the vector del phi. Means along the different vector we can find the derivative, we can find its value. So the value is different for each of these vector, the value is different. Okay, so the value is always maximum, that value of dd is always maximum in the direction of the vector del phi. It is the property of the directional derivative that the dd is always maximum in the direction of the vector del phi, and its maximum magnitude of the directional derivative is given by the magnitude of del phi. So let us start our today's topic, that is the properties of directional derivative. Let me share the PDF of today's lecture with you. Okay, see the PDF. I've written here the same properties. The dd is always maximum. Already explained that we can find that directional derivative along different direction of vector. Okay, means we'll get the different value for each vector, and that value, the dd, is always maximum in the direction of which vector? In the direction of del phi only. So this is the first property that we are going to use now in solving the example. And the second one is the maximum magnitude of the directional derivative is given by the magnitude of del phi. Okay, so these are the two properties. Is it clear, the property, to all of you? You can reply to your chat box so that I can move towards the next example. Yes, is it clear, both the properties? We can find the dd. Yes. Okay, I got the replies from so many students. So now we can move towards the example. Let us see how to use it. Same. The first example, in what direction? Hmm? In what direction that dd of this phi, this function, at this point is maximum? In what direction is the question. And the next question is the what is maximum value of the directional derivative. So we know the property that the dd is always maximum in the direction of del phi only. Okay, so that's why we'll find out here the vector del phi, and along which that directional derivative will be maximum. So first of all, see, let us write here phi, then write the definition of del phi. Hmm. Then substitute here the values dabba phi by dabba x, dabba phi by dabba y, dabba phi by dabba z. Substitute all the values here. Okay, just take the derivative. With respect to x, it will be 2x yz cube. With respect to y, derivative will be what? X square z cube. And with respect to z, the derivative is 3x square y z square, right? And then put the value 2 1 minus 1. Hmm, means x as a 2, y as a 1, and z as a minus 1. So you will get this vector. Hmm. So right here the property after that, the dd is always maximum in the direction of del phi, and we know the value of del phi now. Already we have find here the value of del phi. So this implies goes to that dd is maximum in the direction of the vector minus 4i bar minus 4j bar plus 12k bar. Okay, then the next question is, what is the maximum magnitude of directional derivative? So the maximum magnitude of the directional derivative is the magnitude of vector del phi. Okay, so magnitude, just take the magnitude of this vector del phi. This is the vector del phi. Let us take its magnitude. Okay, magnitude of del phi, that is under root of minus 4 square plus minus 4 square plus 12 square, that is the under root of 176. It is the maximum magnitude of directional derivative. Okay, so is it clear about both the properties and example number one? If there are any question, you can type in chat box. I can see your question. So please, if you are having any question, you can type in chat box. And so no question whether the top example is clear to you. Once I get the reply, then I will move towards the next example. Okay. Okay, so I got the replies from so many students. So now I will move towards the next example, example number two. Okay, so see what they are given in the given the example. If the directional derivative of phi, this is the function phi, at this point has maximum magnitude 4, hmm, means maximum magnitude of dd is given, that is 4, and we know that maximum magnitude of dd is what? It is the magnitude of del phi, means it is nothing but the value of del phi. They have given the value of del phi in direction parallel to the x-axis. What they have given, that dd is maximum in direction of one vector, okay, that is the vector del phi, and that vector is parallel to the x-axis. Are you getting the meaning of question? First of all, understand the question. Maximum magnitude is given, that is the this is magnitude of del phi is given, and it is maximum in direction parallel to the x-axis. Okay, so we know that dd is always maximum in direction of del phi, and that del phi is parallel to the x-axis. Similar question. Okay, means what? That two lines means two vectors are parallel to each other. Which two vector? One is del phi and another one is the x-axis. These two are parallel to each other. Now we are going to use this thing for finding the values of a, b and c. If the two vectors are parallel to each other, then unit vector along them are same. Is it clear? Okay, if the two lines, two vectors are parallel to each other, then unit vector along them are also same. So we are going to use this thing. We know that the unit vector along x-axis is I bar. Along del phi means it is del phi cap. Okay, so let us move towards the solution. Okay, solution of example number two. So see, phi is given. Hmm? So as we are going to use this equation, see this equation. Hmm? We are going to equate the unit vector along these two vectors because these two vectors are parallel to each other. As they are parallel, unit vector along them are same. So as we are going to use this equation, means we require to find out the value of del phi. So first of all, in the first step of the example, we'll find del phi. Okay, del phi. I've written the definition here. Then again differentiate phi with respect to x, y, and with respect to z. Substitute here these values. Okay, phi with respect to x means what? This x will be 1. It is ay plus again this xy will be 1 means plus cz. This term will be 0. When you differentiate with respect to y, so it is this y will be 1, so it is ax, and again this y will be 1, so it is bz, and this term 0. Okay, likewise you can differentiate with respect to z, you will get this term, and you have to find del phi at the point 1 1 1. That is, put x equal to 1, y equal to 1, and z equals to 1. You will get this vector del phi. Okay, now after this write the property here, that dd is always maximum in direction of del phi only. This is the property that we know. But what they have given, that dd is maximum in direction of x-axis they have given. They have given this thing in example, that dd is maximum in direction parallel to the x-axis, right? So this implies goes to our direction of del phi and x-axis are obviously same. And as the direction of del phi and x-axis are same, unit vector along them are also same. Because I have already told you that if the two lines are parallel to each other, their unit vectors are same. Therefore, unit vector along del phi is equal to unit vector along the x-axis. Unit vector along del phi, that is del phi cap, and along x-axis, what is the unit vector? It is I bar. Hmm? What will be unit vector along y-axis? Yes, can reply to the chat box. Along x-axis, it is I bar. No? Yes, correct. J bar. Pranav has replied. It is J bar. Pranav, Adarsh, Rutuja, Roshan. It is the J bar, right? And similarly, along the Z axis, it is the K bar. So it is equals to I bar. Now del phi cap. Cap means the unit vector, right? And A cap, that is nothing but what? A bar upon its magnitude. So del phi cap means del phi upon its magnitude equals to I bar. Now you just shift this term of denominator to the right hand side. Hmm? See, I have shifted here the term. Then maximum magnitude of dd is given. Startingलाच तुम्हाला explain केलं मी हे. It is already given magnitude of del phi is equals to 4. So we'll put that value here. इथे substitute करायचे. Also, we are having the value of del phi now. So let us substitute that value here. Okay. Then magnitude of del phi, that is 4. So I have substituted here. So that to the right hand side, only 4 I bar is there, correct? Only 4 I bar. J and K is not there. That's why I have written there 0 J bar plus 0 K bar. Okay. Because after the step, we'll have to compare the coefficients of I, J and K. Hmm? Coefficient of I bar, that is A plus C. Here coefficient of I bar is 4. So A plus C equal to 4. Then coefficient of J bar A plus B, and here coefficient of J bar, that is 0. Coefficient of K bar B plus C, and here K bar, it is 0. So you will get these three equations in three unknowns A, B, C. Solve the equation by using calculator. All of you solve these equations in calculator. Go to the equation mode button 3 times. Okay. Equation mode, unknowns, three unknowns are there. Then put these values. Yes, all of you solve the equation in calculator and check whether you get the same answer. After getting the answer, reply me through your chat box. Yes, I think all of you are having the same answer. Hmm? Just solve these three equations. Yes, so many students have given me the answer. Okay. Yes, yes. Okay. So let us move toward the next example. Now, similar type of examples are there. Okay, remaining examples are of similar type. Just see, in this example, we were having the direction parallel to the x-axis. So in the next example, you can see hmm, the difference is of very similar type. Just the difference is that difference is we're having here the direction parallel to the z-axis. That is the difference. So this is the step. This is the different step between this is the difference between the previous and this example, that del phi cap is equals to the k bar. Okay, because it is unit vector along z-axis will have to take unit vector along z-axis will have to take, which is nothing but the k bar. That is the difference only. So again, start with the first step, that is we'll find del phi. Again, write the definition. Okay, You can take derivative here with respect to x, y, and z, and at the point 211 evaluate its value. Okay, so after getting this value, write here the property that dd is always maximum in the direction of del phi only. But what they have given that the dd is maximum along the z-axis, means dd is maximum in the direction parallel to the z-axis they have given, right? And this implies goes to what? Direction of del phi and the z-axis are same. Again, we'll use the same concept. That is, if unit the direction of the two lines, two vectors are same, unit vector along them are also same, and that's why the unit vector along del phi is equals to the unit vector along the z-axis. Along del phi, that is del phi cap, means it is del phi upon its magnitude, and z-axis is there, so it is k bar. Again, I have shifted this denominator to the right hand side. Maximum magnitude, that is the magnitude of del phi they have given, which is the 12, right? Here also I have written the same thing. Magnitude of del phi they have given, that is 12. So I have substituted that value of del phi here, and to the left hand side I have substituted the value of del phi. Okay, to the right hand side only k bar term is there, means 0 I bar plus 0 j bar. Now compare the coefficient. A plus 4c equals to 0, 4a plus b equals to 0, and b plus 8c equals to 12. And solve again these three equations. Check whether you get the same answer. A as a minus 2, b equal to 8, c equal to 5, c equal to 0.5. Just check and reply me to your chat box. Just check whether you get the same answer. Yes, Roshan has replied. The same answer. Yes, Iraj. Abhishek has also replied that the same answer. Okay, so now, yes. Okay, okay. So all of you are having the same answer of this. Just you have to solve this equation in calculator. You will get the same answer. Now, let us move toward the next example. Yes, same answer. Okay. So move toward the next example. Example number 4. etc. Now again, yeah, it is of similar type. Just in the previous two example, that dd was maximum in direction of either x-axis or either z-axis was the given information. But now in this example, you can see the difference here that dd is maximum in direction parallel to the line. Means instead of giving the x-axis or y-axis, they have given what? The line. Okay, now again we are going to use the same thing, means we are going to use this thing, unit vector along the del phi is equal to unit vector along the line, right? So for that you will have to find the direction vector. Line is given, na? And now we already discussed in the last lecture that how to find the direction vector from the equation of line, right? How to find the direction vector. Direction vector will be what? 2i bar minus 2j bar plus k bar. If we are having the equation of line in the standard form, x minus x1 upon L equal to y minus y1 upon m equal to z minus z1 upon n, then the direction vector we can write, and hence we can find its unit vector. So again, start with the example. That is the first step of the example, phi, then del phi. Hmm. Again, substitute here these values, phi with respect to x, with respect to y, and with respect to z. So substitute that values here. Just take the derivatives and substitute the value, and then put the point 1, 1, 1, x1, y1, z1. You will get this vector. This is the vector del phi. Again, write the property that dd is always maximum in the direction of vector del phi. But given that dd is maximum in the direction of parallel, to this line. So along this line, this is the direction vector. See the denominator drs. From drs, we can write the direction vector, right? So direction of this implies goes toward direction of del phi and the line are same. And as the directions are same, unit vector along del phi is equal to unit vector along the line. Unit vector along them are same. Okay, and hence unit vector along del phi is del phi cap. Along a bar is a cap. So del phi cap, that is del phi upon its magnitude. A cap, that is a bar upon its magnitude. Now I have just shifted this del phi, magnitude of del phi, to the right hand side. You will get this equation. Now put all the values here. Substitute here del phi, correct? Then substitute here the value of magnitude of del phi, 15. Magnitude of a, that is 3. Okay, and a bar, that is the 2i bar minus 2j bar plus k bar. Now just simplify the right hand side. 3 5s are 15. Okay, 3 5s are 15, and then you multiply this 5 inside this bracket to the vector. So it will be 10i bar minus 10j bar plus 5k bar. Again compare the coefficient of I bar, j bar and k bar. You will get this equation: 2a plus c equal to 10, a plus 2b equal to minus 10, and b plus 2c equal to 5. So check whether you get the answer again by using calculator. Solve these three equations having three unknowns. A is 20 by 9. Okay, A, that is the 20 by 9, B, that is minus 55 by 9, and C, that is 50 by 9. Just check whether you get the same answers. You may get the answer in point. Okay, in fraction. पॉइंट मध्ये आन्सर येईल तसं लिहिलं तरी चालणार आहे. जे पॉइंट मध्ये येत असेल ते आन्सर टाइप करा चॅट बॉक्स मध्ये अँड सेंड मी दॅट आन्सर. Just solve these three equations in calculator and tell me the values of ABC. जे काही पॉइंट मध्ये आन्सर येत असेल ते तुम्ही चॅट बॉक्स मध्ये लिहा. Can send me that answer through your chat box. Yes, A equal to 2.22, then B minus 6.11, and C equal to 5.55. Yes, correct. Aditi, Shubham, Rutuja is replied. Yes, C equal to, yes, correct. Yes, I think all of you have the same answer. Yes. Okay, all of you get the same answer. So now let us move towards the next example. Again, it is of very similar type. Next example. Is any difficulty in this example? Can we move towards the next example? If any question, any difficulty, you can write in your chat box. Okay, so now let us start the next example number 5. Again, you can see it is of very similar type. If the DD of this phi has maximum value 12 in the direction parallel to this line. Just make one correction here in the question. It is 2, not 3. Just make one correction. It is 2. This one. This is 2. Z minus 1 upon 2. And then find the values of ABC. So now again the same way, phi, then del phi. Differentiate phi with respect to x. With respect to x, what will be the derivative? It is a plus c, right? With respect to y, what will be the derivative? It is a plus b with respect to y, and with respect to z, it will be b plus c. Right? Just see that term z, its derivative. So it is del phi. Now no point is there. In fact, there is no need to put the point because already we are having del phi here, which is free from that xyz. Hmm, correct? So this is your del phi. Now again, in the same way, del phi is always maximum in the direction of del phi. That sorry, del phi, it is dd. dd is always maximum in the direction of del phi only. But what they have given? They have given that dd is maximum in the direction of this line. So again, right here the direction vector. Write that direction vector. Now this implies goes to the direction of del phi and the line are same. And as the direction of del phi and the line are same, this implies goes to the unit vector along del phi is equals to unit vector along the line. Along del phi, that is del phi cap, equal to along the line, that is a cap del phi upon its magnitude, and the right hand side a bar upon its magnitude. So del phi, you just shift this magnitude of del phi to the right hand side, so you'll get del phi equals to magnitude of del phi upon magnitude of a bar to a bar. Now substitute here the value of del phi. Right hand side magnitude of del phi we have substituted here, denominator magnitude of a bar. A bar, its magnitude. See, this is your vector a bar. Its magnitude, that is under root of 1 square plus 2 square 4 plus 4. That is root 9. That is 3. So it is 12 upon 3 into the vector a bar. So 3 fours are 12. Then you multiply this 4 inside the bracket to this bracket. You will get 4i bar plus 8j bar plus 8k bar. And now again compare the coefficient of I, j and k on both the sides of the equation. So a plus c is 4, a plus b is 8, and b plus c equals to 8. And again, all of you solve these three equation in calculator, three equation with three unknowns, and give me your answer through the chat box. Solve these three equation by using calculator. Okay, get the same answer. Others has replied. Yes. Shubham, Radhika, Abhishek has replied. Get the same answer. Roshan, Rudaya. Okay, all of you are having the same answer. Okay. So this is all about the topic directional derivative. In the last lecture, we have seen some example of finding the directional derivative, and in this lecture, we have seen the examples based on the properties of directional derivative. Okay, so this completes the topic directional derivative. One compulsory example will be there in exam, depends on the topic directional derivative. So now in the next lecture, again, we are going to start very important topic, that is the irrotational vector field. Okay. So again, there is a compulsory example on that topic, compulsory example of 4 marks in theory exam on irrotational vector field, irrotational and the scalar potential phi. So that will start in the next lecture. Okay. If you are having any difficulty, any doubt, you can ask me, you can call me, WhatsApp me. Okay. So complete your notebook. Stop.